This is Dr. K. Rajendra Prasad. I am working as professor and head of the department for CSE Cybersecurity. Today we are going to discuss what are the phases of compiler. We have identified totally 7 important phases of the compiler, which are lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generation, mission independent code optimization, code generator, mission dependent code optimizer. Here the first phase of the compiler is lexical analyzer. So what is the lexical analyzer? The aim of the lexical analyzer is it separates the tokens for given source program language statement. Means the user is typing to the program in the form of the source language with several number of program language statements. So each and every language statement or instruction that can be defined with various tokens. So recognize the tokens or separating the tokens, that is a challenging issue that can be performed by this lexical analyzer. So read the stream of characters, making up the source program and groups the characters into meaningful sequences called as the lexemes. Here token or lexeme, the meanings are same. Means whatever the user is initially typed the program, so you have to go for one by one, means line by line program. So each line they have some, it can be arranged with some various number of tokens. So the duty of the lexical analyzer is it separates the tokens. It should identify what are the valid tokens. That is the aim of the lexical analyzer. So here the lexeme or tokens, the meanings are same. So here some cases totally for we define the two types of tokens. One is called as value tokens. It's called as value tokens. Non-value tokens. Another one is non-value tokens. In the case of value tokens, we should follow this kind of syntax. Means what the token name and what are the attribute values. For example, you consider this is a statement. So this statement is there in the one of the source program that is given by the user. So in this source program, so what are the tokens you should identify nothing but by the lexical analyzer. So we identify totally for 5 different tokens. These are for 5 different tokens. So lexical analyzer, it reads some source language statement, then it converts into some various tokens. Our aim of lexical analyzer is separating the tokens of given source language statement. So it separates the tokens like this: A, capital A equal B, capital S, and capital C. So this I think we identify the tokens from the given language statement. Here the task is what are the value which are having the value. Except operators, remaining other operands have the values. What are the operands? A, B, C. These are the operands. So for these cases, we should follow this kind of syntax. Token name, comma, attribute value. So A is having the value. You consider A is some identifier. You know what the meaning of the identifier is. So identifier that comes with the variable declaration. The identifier that should start with some letter only. So you know the identifier rules. So now you know that the capital A is one of the identifier. So for this identifier, I think what the value? The value that can be stored in some data structure, symbol table data structure in one of the entries. Suppose I am assuming the value of the capital A that will be stored in the first entry of the symbol table. So it can be defined as ID, comma 1 or identifier 1, comma 1. So second identifier is B that can be defined. You follow the same syntax: token name, comma, attribute value. As per the syntax, it is considered as ID2 and also 2. So like that here, last one is C. C is a third identifier, ID3, comma 3. So what are the ID1, comma 1? Nothing but ID1 is some identifier. That is for this example, using ID1 is capital A. The value of the capital A is stored in the first entry of the symbol table location, first record of the symbol table location. That's why here it gives the 1. In the symbol table, the next second record entry that may be take the value of the attribute is capital B. B is the ID2. C is the ID3. So we have to go for this kind of assumption in the lexical analyzer. So the lexical analyzer, the main role is it reads the stream of characters, making up the source program and groups the characters into meaningful sequences called as lexims. Sometimes I think we have defined the sequence, but there is no meaningful. Suppose I'm saying the same statement A equal to B plus C. I want to take the this only for one group, A equal to some group. So here there is no meaning. Only for you have to separate in the A and separating the equal method, there's some meaningful. So that is the idea of meaningful sequences. Groups the characters into meaningful sequences. And we have to go for, so another example is now let me show the another example. The example is I am writing AB equal to B plus C. Here we have to grouping totally for A and B. We cannot separate A and B. It is incorrect. It is incorrect. We have to group in the meaningful sequences. Group the characters. Group the characters. Group the 22 characters as one identifier. One identifier. This is one identifier. This is another identifier 2. This is another identifier 3. Means here the challenge is groups the characters into meaningful sequences. That's the challenge. That can be uh, performed by the lexical analyzer only. So means initially it reads the some source language statement, then it groups the characters as per the meaningful sequences. So once we have to obtain that particular group of characters is a meaningful sequences. That's a conclusion you got. It is called as lexic, or it is also called as token. So this is the idea about lexical analyzer. In the simplest way, we have to say that what is the lexical analyzer? But it reads the some program language statement, then it can divide the program language statement into some number of tokens or some number of lexims. This is the idea of lexical analyzer. Second phase of the compiler is syntax analyzer. The syntax analyzer is very important from the program language point of view, because of when you're compiling any language, any program, any source program, sometimes you have to getting the errors, sometimes you are not getting the errors. How nothing but with the help of the syntax analyzer only, you are getting the idea of whether the errors are found in the program or not. Role of the syntax analyzer is it will verify the syntaxes or grammatical rules. As per means the compilers know that what are the grammatical rules of the particular corresponding language. As per that, the user is given the program language statement or not. So it will verify that so the syntax of the program language statement as per the grammatical rules of the particular programming language. So this is the idea of syntax analyzer. The second phase of the compiler is called as a syntax analyzer. That is we are discussing now, and it is also called as parsing. Syntax analyzer and parsing, the meanings are same. Syntax analyzer and parsing, the meanings are same. It uses the output of lexical analyzer. Means in the previous page is lexical analyzer. What happens here is the program language statement that can be divided into some number of tokens. A separate tokens are generated. So that is the output of the lexical analyzer. You take that is the output consider as the here input of the syntax analyzer. So that's why here you can discuss it uses the output of lexical analyzer. That is, parser collects the token generated by the first phase of the lexical analyzer and create after taking the output of the lexical analyzer. Then you can arrange the output of the lexical analyzer like tree-like structure, tree-like intermediate representation. This is also called as syntax tree. This is also called as syntax tree. Means here we should follow the two important steps in the syntax analyzer. The first step is you take the output of the lexical analyzer. Second step is after taking the output of the lexical analyzer, you should arrange all obtained separate tokens according to the some tree-like intermediate representation. That kind of tree is called as syntax tree. So here we have to define what the syntax tree is. Syntax tree is exactly, I think, in the form of the tree only. It also has the root node and also some interior nodes, some leaf nodes. So these are the two components we should identify: interior nodes and also leaf nodes. Interior nodes, in addition to that, we define the root node also. So here interior nodes, what is the basic idea of interior nodes of the syntax tree? Nothing but here you take any arithmetic expression or assignment statement. Here we should identify only for two important things: operands and also operator. So it means here where should represent the operators? Nothing but in the interior nodes. In the interior nodes that can be used for representing the operations. Interior nodes that can be represented for the operations. So what is the basic idea of leaf node? Nothing but in the leaf node you should define only with the operands only or arguments is also called as arguments. So for example, you are taking a equal to b plus c, and what happens in the lexicon is these are separated. A is separated, equal is separated, b separated, is separated, c is separated. We should arrange in the syntax analyzer all these tokens according to some syntactic structure. Means is like here this is a root node, this is the interior node sir, plus b and c. So you have to see that these are the interior nodes, root node and interior nodes. And what are the leaf nodes are? Only for arguments, only for the operands. So this kind of output you are generating. So when you're using the syntax analyzer, means lexic analyzer will do or will convert the given source language statement into some number of tokens, or it supplies the tokens for the given program language statement. So after taking the separated tokens, we should arrange all separate tokens into account to some syntactic structure of the as per the grammatical rules. Here we can use some tree like intermediate representation. This kind of representation is called as syntax tree. So this is the example for understanding purpose. I am taking a equal to b plus c, and tokens are separated in the exit analyzer like this. And after taking this input of this syntax analyzer, you are expecting what the output is generated syntax tree. Means so while generating the syntax tree, if anything is missing, operator is missing or operator is missing, definitely you are getting the error. Something is missing, or sometimes you are also getting the problem of some syntax errors. So means all type of syntax errors that can be verified. So after arranging all separate tokens in the form of tree like intermediate representation. So this is the idea of syntax tree. So with the help of syntax analyzer, so you are getting the benefit is so it will generate the error report. We have any errors found, error report. Otherwise no errors, then you go for the next phase is semantic analyzer. So the same idea is explained. What the role of syntax analyzer with the help of one more example is. Here I am taking this is the example. Position equal to initial plus rate into 60. So what the symbol table? What the identifiers? Identifiers position is stored in the first location. The symbol table. Symbol table is nothing but some kind of data structure. It may be there in the main memory we are assuming, and initial is another argument that can be stored as the second record. Rate that can be stored as the third. Now we are using this lexic analyzer. We cannot call directly for the arguments position, rate, and 60. We can call as generalized identifiers. First identifier, and another token is the equal token. Another token is the second identifier, that is the initial, and another token is the operator place. One more token is ID comma 3. So like that, these are things we have to generate. This is the output of lexical analyzer. Is this I think usually the user is given the program language statements like this. After applying lexic analyzer, what it will do nothing but it separate the tokens like position comma, equal comma, initial comma, place comma. So whatever the position is identifier. We generalize position is identifier. So one nothing but the first identifier is the position. The first identifier is the position. One refers to the first record of the symbol table. The second record of the symbol table take the another identifier is initial. And third, you go for the third record is rate. Third record is rate. Like they try to understand. So what is the lexical analyzer output is? You consider this output is just for you are separating the tokens of the program language statement, or any arithmetic statement, or any assignment statement, or any other statement also. Any statement is given in the program language. the statement that can be divided into some number of separated tokens. So this I think output of the lexical analyzer. So you have to see when you apply the syntax analyzer for the output of this output of lexical analyzer, you consider this output becomes the input of the syntax analyzer. So it can arrange according to the some tree structure. This just like the tree intermediate representation. So when you arranging all these operations and operands, all you have separated as per the idea of lexical analyzer, and you can arranging according to the grammatical rules of the programming language statement. So what the grammatical rules we should follow any operator that can be connected by with two operands. These are commonly we have to follow for this example. So we have to check for that semantic consistency. Maybe for the coming case we have to observe in example. So this case is just you have to syntactically all tokens are arranged or not. So you have to verify that kind of thing. You have to verify that kind of thing. What the verification is? Syntactically all tokens are arranged or not. So here there are no errors, then only you are going to the next phase is the semantic phase. So syntax analyzer will observing the syntaxes of program language statement. Will take the output is of a lexical analyzer. It is considered the input of the syntax analyzer. So here we have to go for another third phase is semantic analysis. Here you are looking only for semantic consistency only, because syntax verifications are already done in the previous phase. The semantic consistency here we have the total important part of semantic analysis, type checking and type conversion. So in the type conversion, we sometimes we should follow the implicit type conversion, or is explicit type conversions. Suppose automatic type conversion is not possible, then there is possible to get the errors due to some semantic problem. So that idea is called as a semantic consistency. The semantic analyzer uses the syntax tree and the information in the symbol table to check semantic consistency with the language definition. So this is I think idea of semantic analysis. So the important parts of the semantic analysis is type checking and also type conversion. During the type checking, suppose the operands are not matched, then we have to getting the possibility is a semantic error. Suppose you want to overcome that error, you may use the type conversion. So you have to see this already done. Exit analyzer, what understanding is that you have to separate the tokens here of the program language statement, and you have to take this output of the syntax analyzer, and syntax analyzer this output of the syntax analyzer. You take this output of semantic analyzer, and then finally you can verify what the 60 is. So what are the identifiers? Suppose I am assuming these identifiers are float values only. Here also you must be allowed the float. That's why we use some type conversion. That's why into to float. Suppose automatic type conversion is not possible, explicitly you can represent the one syntax of into to float, but the 60 that will be converted into 60.0. So all are float values. Okay, why not use also float? So that idea. Otherwise, we have to get in the semantic inconsistency. Because the question is, so you may perform the operations only for float values only. That's the question. By mistake, I given the 60. You may convert that 60 into 60.0. Otherwise, honestly, you have to get in the some semantic consistency problem. So semantic consistency, that you want to maintain semantic consistency, you must use the semantic analyzer. So that's why here you are assuming all three identifiers are float values. The fourth one also must be float. So how to resolve this issue? Nothing but you may use some kind of type conversion int of float. Nothing but this int is a value that can be converted to the float value. Now all values have become a float. Then you have to getting the result also float. So this is the idea of semantic analyzer. So we have to see another fourth phase. Fourth phase of the compiler is intermediate code generation. Here, most frequently, you are using the 3 address code instruction. It may be triple, quadruple, or indirect triples, and sometimes syntax tree. You are getting the details of this intermediate code generation in coming chapters, but you have to know what the basic idea of intermediate code generation. Before generating the target code, the machine wants to some simpler forms of the statement. Suppose you have given any longer statement. That longer statement that may be divided into some kind of simpler statements. The simplest statement that can be easy to translate in terms of mission code. So that is the main object of intermediate code generation. So compiler construct one or more intermediate representation during the translation process of source program to target program. So here we are using the tree underscore instruction and also syntax tree. So these are the popular forms of the intermediate codes. For the purpose is easy to produce and once the simpler statement is obtained, so you can easily to translate into target mission code. Means you try to analyze it. Suppose lengthy statement is given, translate to mission code, how much time? Simple statement is given, translate to mission code, how much time? Not only for time, we can analyze some memory also. Means for improving the memory efficiency, for increasing the fastness of the program, okay, you must apply the intermediate code generation. So previously already I discussed all these things. Now we have to see the intermediate code generation. So here I am using the what kind of address code is three address code. Three address code. What do you mean of three address code? So I will give the details in the coming classes. But for understanding of this intermediate code generation, just I am introducing the idea of three address codes. Maximum is it allows, at most is it allows only for three operands. Only for three operands. So three operands means not more than three operands. So it may allow zero number of operands, one single operand, two operands, or three operands. So you have to check in every statement maximum is three operands only. Here how many operands are there? Two operands. What are the operands are? T1 and also value is 60 and also value is 60.0 because after making the conversion you are getting 60.0. Two operands. Here how many operands are? Three operands. This is also three operands. This is also one operand. So before that one big statement is there. What the statement is given is so the form is equal some identifier here and identifier plus identifier and multiplied with the another identifier. So you have to totally count how many number of operands. Four number of operands. So this statement that can be divided into some simpler statements. Four simpler statements. Here what happens? What is the advantage of one? We try for reducing the number of operands in every simpler statement. Here total of four operands are there, but here reducing the total number of operands. And you have to make the execution of each and every statement is also very simple. And translating the conversion of simple statement to target mission is very easy. So converting the largest statement into mission code is very difficult. So that purpose we are using the some intermediate code generation. Next come to the part is code optimization. So after obtaining the intermediate code generation, then you can apply if there is any possibility you may apply the code optimization. So code optimization nothing but you think in what way you have to reduce the number of lines. In what way you have to reduce the complexity of the program. That basic idea you are getting here in the code optimization. So here you should observe this code optimization totally for machine independent. Means in one system you have to done the any code optimization technique, other system also easily allowing the same modifications. That's called as machine independent code optimization. Means we have done in our system the coding modification. The same coding modification will be allowed in any other system also. That kind of idea is called as machine independent code optimization. It attempts to improve the intermediate code so that target code will have improvement in terms of the size of the operands, or size of or total number of lines it may be reduced. So we have to see previously how many number of lines you have got. You are getting the 4. Okay. So count out is when you apply the intermediate code generator here, the this only for single statement that can be converted into 4 number of simpler statements. Of course, the each and every statement is simpler, and translating each and every statement into mission code is also very easy process. But you are looking for the number of simplest statements is 4. It's a very large. But here number of statements are only for 1. So because of I think more number of operands we have done this intermediate code generation. However, number of operands are reduced in the simplest statements, but we are getting the problem is number of simplest statement may be increased. So you want to reduce this value 4 to 2 or 4 to 3. In that case, you may apply this code optimization technique. So you have to see that so how it can be reduced. The same logic that can be converted into some other idea. Finally, you have to obtain the same result whether you're using these four when you're computing when you're executing these 4 lines or you go for executing these 2 lines by getting the same answer. But what is the modification of everybody here? Some number of lines are some number of 4 lines are replaced with some other new lines only for 2 number of lines we have to put in here. Means number of lines are reduced. Number of lines are reduced to 2. But when you use the 4 simple statement, here we are getting the same answer with after applying the code optimization answer. Here you observe thing is here also we follow the intermediate code generation. Maximum allows only for how many operands? 3 operands. Here also 3 operands. Here also we should follow the same concept. Okay, 3 underscore nothing but at most is in every statement you have the 3 operands only. At most is 3 operands only. But what is the advantage here? Nothing but number of lines are reduced after applying the code optimization. Means you may use different kind of logic that depends upon the user idea or user intelligence. So based upon user intelligence, and he think okay how the code will be optimized. So after applying the code optimization, the 4 number of statements for this example may be reduced to the 2. So in this way, so you have to save the time. Means automatically the execution becomes faster. Running time it may be reduced. Execution becomes faster, and memory efficiency also improved because of we are running only for 2 statements only, not for the 4 statements. So finally, what is the advantage? What is the advantage of code optimization itself? Code optimization improves running time of the program without slowing the completion time. Means it increases the fastness of the program, and also memory efficiency also increased. This is the idea of code optimization. Another one is code generator. What the code generator is? So code generator takes as input of the intermediate code generation of the source program, or from the code optimization also it takes the input and maps directly into the target language. So compilation nothing but compiler duty is it converts the source code into some other mission code, or it converts the source code into target code. So here target code may be mission code and nearby the mission code. Here I am taking the target code is the assembly language code. Because of in the assembly language code, we must mention the what are the registers. These are nothing but some kind of memory. Here how can the data will be stored, and how the I think addition, multiplication, basic operations are performed for the integers and as well as the float. You know each and everything here in the code generator. So means it takes the output of either intermediate code generation or code optimization, because the code optimization is the optional phase. Suppose you apply the code optimization, it takes the output of the code optimization, and then for the code optimization result, you can apply the code generator. Means I show the example is. So this is the I think idea of intermediate code generation. Here I am taking the intermediate code generation code. This is the output of intermediate code generation, and here we have to see the instructions. These instructions are understandable by the mission. It's not directly mission code. We should understand these kind of assembly language instructions. LDF nothing but load float value. MULF nothing but multiplication of the float two float values. Again load float value and addition and store the float value. Means you convert your intermediate code into some kind of assembly language code. Using the assemblers, you convert this assembly language code. We convert this assembly language code. I am writing here clearly. This assembly language code. So you convert this assembly language code into mission code. So which one is performed? But the translator is called as assemblers. The translator is called as assemblers. So finally, you have to see that the compiler is nothing but It's a translator. It converts source program to mission code. But here the converter source code to the assembly language code, then assembly language code that can be converted to the mission code. So that is how to observe using totally for 5 phases of the compiler. So in the along with the 5 phases, you must know awareness about the symbol table. It is some kind of a data structure. You want to store the values of the some arguments, and you can keep each value that is considered as one particular record in the symbol table. By accessing the entries of the symbol table, you must generate the some kind of intermediate code generation. So this is the idea of symbol table. Here the purpose of symbol table is you go for quickly to store and retrieve the data. So that is the purpose of the symbol table. So along with the 5 phases, you must know the symbol table also. So this is the final view of the compiler. What happens here? The final view is so you are taking this your language statement. Any user is given some language statement. Tokens are separated here. This is one separate token. This is another token. Like that, all tokens are separated. This is a lexical analyzer. Lexical analyzer will do the separation of the tokens of language statements. After that, these all separate tokens that can be arranged like tree structure. It's a tree structure. And after that, if any semantic inconsistency is there or not, that will be verified by the semantic analyzer. Yes. So for resolving the semantic inconsistency, here I am applying some type conversion because of here I am using the all are float values. They also must be float value. That's why we should convert the 60 to 60.0. And after that, you can apply the some intermediate code generation for the output of semantic analyzer. You can apply intermediate code generation. Means I am taking the here the concept is a three address code. I will tell you in coming classes in detail what the three address code is. But up to now, you know what the basic idea of three address code is. It allows at most is at maximum is 3 operands only. At maximum is 3 operands. You check here 2 operands is good. It's 3 operands. Okay. There's also 3 operands. There's also 2 operands. In any statement, we have the only for below of 3 operands are equal to 3 operands. Cannot allow the above 3 operands. That's the aim of a 3 address code. So the purpose is, so 3 operands are there in the particular statement, then easy to convert into the mission code. That's the purpose of a intermediate code generation. That's why this lengthy statement, here 4 operands are there that can be converted into some set of simpler statements. You feel here number of simple statements are 4. It is a very large number. You may apply the code optimization. It is the optional phase. This phase is the optional phase. If you have interest, you can apply, or you have the idea, you can apply. So you have, I think there's no possibility for applying the code optimization. It carries this is the output of a code generator. Suppose code optimization is done, then the 4 that may be reduced to how many number of statements are only for 2 statements only. After getting these 2 statements, then you try to convert into some kind of low-level language code. It's called as low-level language code. Low-level language code, because compared to the source code of the high level, low level is somewhat better for understanding point of view of the mission. So it's a low level language. What language is it? Assembly language code. Assembly language code. So here some instructions are given. These instructions are understandable by the mission only. So this assembler, okay, assembler is also some kind of a translator like compiler. It converts this assembly language code into for mission code. So finally, we have to observe the given source code that can be converted into assembly language target code. This is called as target code, assembly language target code that can be converted into again the mission code. So these are the totally for we should recognize how many important phases are totally for the 5 pages. Okay, but mission independent point of view, you may consider as 2 separate phases, but you come to only for code optimization is a single phase only. So again, once again I will explain what are the names of the phases. One is the syntax analyzer, Prior to that, already you know exit analyzer. Third one is semantic analyzer. Intermediate code generation, code optimization, code generation. So these are the important phase you recognized while implementing the compilers of some particular languages. So these are with this example you are getting the what is the final view when you're converting any program language to some mission code. So how the code is converted to the mission code. So during that process, what are the steps you have to following with the help of phases from lexic analyzer to code generator. So this is regard to the today class. Okay, with this we conclude the phase of the compiler. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.